Let's start with the problem of the day from yesterday. Nutrition guidelines suggest 65 total fat grams for a 2,000 calorie diet. How many fat grams are recommended for a 3,000 calorie diet? So probably the easiest way to do this problem is to set up a proportion. 65 fat grams for a 2,000 calorie diet equals, and we want to know how many fat grams would be recommended for a 3,000 calorie diet. So now we can use cross products. 2,000x is equal to 65 times 3,000, which is 195,000. Divide both sides by 2,000. And x is 97.5 fat grams. You got it. Questions? Okay, how about section 6 homework? Starts on page 440. Nothing there? Okay. The part 1 recap, page 444. Okay, then I would like your homework, please. Okay, so part A on page 446, that part was pretty easy. 4 times 2 is 8 square inches. For 3B, we need to convert to square feet. What's the conversion between inches and feet? Is 1 foot. So we need the 12 on the bottom. But notice we started with square inches, so we have to go back to our new fraction and square everything. Now we can cross off the square inches. Multiply straight across and we would have 8 over 144. And divide that out. Round to 4 decimal places. What'd you get?
Okay, so I get from my answer though, it's
Okay, so
that.
and the 5 repeats. Okay, so you have 0.0, 5, 5, and then you need to round the last digit. Is it a 5 or will it go up to a 6?
Oh, it'll be up to a 6.
There you go.
Okay, I was taking the zeros like all the way to the left. That's what I was doing.
Okay, so there's the answer to B. Now part C. What is the area of this paper bill in square miles? So probably easiest if we go back and copy actually what we did in part B. 8 square inches over 1 times 1 square foot over 12 square feet. Oops, that should be inches on the bottom. So we can cross off the square inches. What's the conversion between feet and miles?
Wasn't it like 5,280?
There you go. 5,280 feet in 1 mile. But like part B, we have to go back and square everything. So when we multiply straight across, we still have 8 in the numerator. We're going to have a really large number in the denominator. To take the 5,280 and square it and multiply by the 144. You should get 27,878,400. You did not get that?
Oh, I think I forgot to square the 144.
You don't square 144. It should be 5,280 squared and times 144.
I don't know what I'm doing.
I don't know. Oops, I made a mistake. This 27,878,400 is what you get when you square the 5280. So you need to take that number and multiply by 144. And my little calculator won't even do it. So we're relying on yours, Alexis.
Let me think about it.
What did you get?
I hope I do this in the right order. Wouldn't it be 4 billion? Because I suck at like things.
Okay, well, let's just write down the digits. We have 4,
0.
0, 1, 4, 4, 8, 9, 6, 0, 0. We put the commas in, and there it is. And now you need to divide that out. And I think you should get a number in scientific notation.
Wouldn't it be that divided by 8?
And the other way around, it's 8 divided by that big
that's
number.
why. Okay. Whoa, that's really big.
Okay, so scientific notation, if we round to 2 decimal places, what do we have?
2.0. Or
No, if we round to 2 decimal places,
oh, it'd be like 199 point. Wait. Wouldn't it go behind the 9?
it would go behind that
Okay.
second 9. So
Just making sure.
1.99 times 10 to the
-9.
negative 9 power. So it's that many square miles. Crazy number.
Jeez.
Letter D. How many of these paper bills would it take to cover a living room floor if the floor is 18 feet by 15 feet?
Oh goodness.
Well, we're going to have to figure out how big the room is first, right? How do we do that?
Wouldn't it be 18 times 15?
18 times 15,
270.
270 square feet. Any ideas of what we should do now?
Hmm.
We found square feet earlier, didn't we? Which letter was that?
Oh, that was B.
Letter B, we found the square feet there. And that, again, was a square feet of that paper bill.
I'm guessing you just do 270 divided by 144.
Not 144, though. It's 270 divided by, what was our answer to B?
0.055.
6. Yep.
Oh yeah.
0.0556. So we take the area of the room, we divide by the area of the paper bill.
Alright, well, you put all that down?
4856.115108. Well, if we round to the nearest whole number, what would you have?
It'd be like 49.
No, nearest whole number?
Are we talking about those two?
Not just 2. How many numbers are in front of the decimal point?
Oh, I guess 2 of them are behind 8. Wouldn't it be like 4,900.
Rounding to the nearest whole number, what digit is in the ones position?
The 6.
Okay.
Oh.
Actually, if we did round to the nearest whole number, let me write down the whole thing here. 4856.115108. If we were to round to the nearest whole number, it would be 4,856. But notice there's some left over, so we're actually we need one more bill to have everything covered. So we would need 4,857 paper bills to cover the floor.
Jeez.
Now in the book, they actually rounded to the nearest 10. I'm not sure why they did that. They got 4,860 paper bills. They would not have needed that many. Okay, well, number 4 is kind of hard to do without anyone here. So let's go over to section 8, page 447.
Oh my goodness.
Oh, don't let the picture scare you. It's not as bad as it looks. Okay, alkanes are a type of molecule with only hydrogen and carbon atoms that are joined with single bonds. Single bonds are shown by a straight line connecting a C with an H. The first few straight chain alkanes, C's are in a line, are drawn in the table below. Start with methane, the smallest alkane. Number 1, write the formula for the first 4 alkanes by first counting the number of carbon atoms and then counting the number of hydrogen atoms in the structural formula, and writing these numbers / counts as subscripts on the atom symbols. The first 3 have been done as an example. Draw pictures for the rest of the alkanes in the table and write their formulas. So for methane, we have 1 C and there's 4 H's. So the formula would be C, H, and a 4. So when it's 1, notice they don't write it in. It's sort of like when we're dealing with exponents. If we have an exponent of 1, we usually don't write that in. When we get to the next one, notice now we have 2 carbons, and then they put the H's all around, and there ends up to be 6 of them. For propane, there's 3 carbons, and H's all around. There's actually 8 H's.
So it would be C3H8.
C3H8, that is correct. It's a terrible looking 3. There. Okay, so draw the next one, and then the formula.
Will there be 4 C's?
There's going to be 4 C's. And put all your H's in like they did.
Why don't we add 2 more H's?
So what do you end up with for the formula?
C4H10.
H what?
10.
That is correct. Okay, try the next one.
C5H12.
C5H12. Good. Go on to the next one. I need bigger boxes.
C6H14.
C6H14. You're getting them faster than I can draw them out.
C7H16.
One more time.
C7H16.
H what?
16.
16, yep.
C8H18.
C8H18. Okay, I have a few more H's to put in here to catch up to you. There we go. Now we have the nth alkane. So they're saying CN, what do you think the subscript is on the H? Look at all of our examples. We go from 3 to 8, 4 to 10, 5 to 12, 6 to 14, and so on. How do we get from the first number to the second number? Can we take the first number and add something? So for example, in the first one we have C3H8, so we would add 5. Does that work on the next one? If we add 5, will we get the second number?
You would add 4.
I was looking at this one, so what about this one? See how we start with a 3 and 8, add 5, we get the second one. Does that work here?
Oh no, it goes up.
It goes up, but not by 5.
Yeah, this one goes to 6.
Right.
7.
And then you'd add 7. So that doesn't really help us because we have to do something with the n, which is our first number, to get the second number. So what if we take the first number times 2? So again, I'm looking at the propane one. If we take the first number times 2, that would give us a 6. How would we get to 8?
Adding 2.
Add 2. So if we take the next one, we have 4. If we take that times 2, what would we get? 4 times 2 is?
8.
8. And then how do we get to the 10?
Adding 2.
Add what?
Add 2.
Add 2. Ooh, looks like we might have a pattern. Let's try it one more time. If we take the 5 and we multiply by 2, what do you get?
10. Add 2.
You would get 10, so then you'd have to add 2 to get to the 12. So what we're doing then is we're taking 2 times whatever n is, and we're adding 2 to it. Let's skip all the way down to the last one, just to make sure. So if you take the 8 times 2, you get,
16.
and if you add 2, you do get 18. Okay, let's go to the next page. Number 2. Since the number of hydrogen atoms increases by blank every time the number of carbon atoms increases by 1, there is a blank relationship between the number of hydrogen atoms and the number of carbon atoms. Okay, so go back and look at your table. So notice that the carbon atoms are increasing by 1.
The other ones are
The hydrogens increase by what?
2.
By 2. So that fills in the first blank. What kind of relationship do we have then?
Crap. What do you mean, like a relationship?
Well, it's like what we had earlier when we had a table, and as one increased by a certain amount, the second column increased by a certain amount. What kind of relationship is that?
Oh man. I don't know.
It was a while ago.
Wait. I don't know.
Starts with an L.
Linear?
There
Oh,
you go. Number 3. To represent the relationship between the number of carbon atoms and the number of hydrogen atoms as a linear equation, write the information in the table in the form of ordered pairs. So methane, how many carbon atoms were in methane?
1.
And how many hydrogen atoms?
4.
Okay, so we can write that as an ordered pair. We want C first, which is 1, and then the H, which is 4. Okay, so go ahead, fill in the rest of that table. So there they are. Double check, make sure you have the same numbers.
Yep.
Okay, so on to number 4. Find the slope of the line representing this data and interpret it in words. So we can use a table to find the slope. So look at the H's. As you go down the column, what's happening with the numbers?
They're getting bigger by 2.
Getting bigger by 2. So the slope is 2 over. Now look at the C column. What's happening with those numbers?
They're going by 1.
They're getting bigger by 1. So we can simplify that to 2. So there's our slope. So interpret it in words. For every carbon atom that's added, what can you say?
They're getting bigger by 1.
Yes, that's what the first part means. For every carbon atom that is added, then what happens with the hydrogen?
The hydrogen goes bigger.
By? How much?
Well, it like depends.
As it goes from one to the next.
Oh, 2.
Okay.
Sorry.
Yep.
I thought you were talking about back.
So we're using the slope to get that. For every carbon atom that is added, that's the 1 in the denominator. Then 2 more hydrogen atoms are added. That's the 2 in the numerator. Okay, moving on. Since this data is linear, we can write a linear model that gives the number of hydrogen atoms for a given number of carbon atoms. To date, we have used inductive reasoning to find a relationship between 2 variables. While this process does not require a lot of math, it can be time-consuming and frustrating. Let's develop a procedure to write a linear model from data. 5A. What is the slope-intercept form of the equation for a linear model? We talked about this formula earlier. Do you remember what it is?
Isn't it 3 over 4?
No, 3 over 4.
Oh.
Slope-intercept form. Y equals,
Oh, shoot, that. God dang it, I can't remember what one it was. No, that's not right. It wouldn't be that, right?
no, that's variation equation.
Yeah, I don't even know which one we did the.
That's
What?
getting closer.
Ugh.
Just right above that, where you had your finger. Just above. Higher, higher.
MX
There
plus
you
B.
go. Y equals mx plus b. So just as a reminder, when the equation is in this form, the number in front of the x tells you the slope. And this number at the end that does not have an x, that tells you the y-intercept, and it's always at 0 and whatever that number is. Remember, the y-intercept is a point. Okay, so letter B. Rewrite the formula with the linear model in terms of h and c. Use the table to determine which variable will be independent and which will be dependent. Recall that h is equal to the number of hydrogen atoms and c is equal to the number of carbon atoms. So, which one do you think is really the y? Which one is the x?
I think the Y. I think the Y would be the C.
So the y is the
Wait,
dependent
wait.
one. So does the number of carbons depend on the number of hydrogen atoms?
Yeah. Oh, no, I guess not.
No. If you go back to what we did in number 4, for every carbon atom that's added, 2 more hydrogen atoms are added.
Oh.
So the number of hydrogen atoms depends on how many carbon atoms there are.
Dang it.
So H is independent, that means it's the Y. C then is independent. So there it is with the H and the C. Now part C says substitute the value of the slope for M. What did we find for the slope earlier?
Y equals mx plus b.
What was the slope?
Oh, m equals 2 over 1 equals 2.
Okay, equals 2. So H is equal to 2C plus B. Let's go to letter D. To complete the model, we need to find a value for B. One way to do this is to substitute an ordered pair into the equation and solve for B. We can do this using the first ordered pair 1, 4 and substituting in C equals 1 and H equals 4. We have, so we're putting the 4 in for the H. We have 2 for the slope, 1 for C, and then we have plus B. So far, so good?
Mm-hmm.
Okay, so now we need to solve this. What do we do first in solving it?
Solving this one.
Mm-hmm.
When you do like the 2 and the 1, that's
Yep,
2.
2 times 1 is 2. So 4 equals 2 plus B. What's the next step?
Then you have to get the 4 with the 2.
Right?
Wouldn't you subtract it?
Subtract what?
The 4 by the 2. Or the 2 by the 4.
So you're going to take what minus what?
4 minus 2.
Yep,
Sorry.
that's correct. You're going to subtract 2 on both sides. And 4 minus 2 is?
2.
So now we know that B is 2. They didn't ask us to say this, but that would also mean that our y-intercept would be the point 0.02. Now we want to write the completed linear model. So we're going to put the h and the c back in. The slope is still 2. And now we know that the y-intercept is 2. So there's our equation. In 5F, we are using mathematical notation. In the last row of the table in the Explorer, we were using chemistry notation. So go back and look at the last table, that last piece, back on page 447. We had CNH, and then we found the subscript to be 2n plus 2. Looks very, very similar, doesn't it?
Mm-hmm.
But we had to kind of use guess and check to figure it out back there. This way we had step-by-step process. Number 6. Explain the meaning of the y-intercept in the model if possible. So we said the y-intercept will be 0, 2. But does that make sense? That would mean we would have 0 carbons and 2 hydrogens. Does that make sense? Does that make sense?
Actually, yeah, wouldn't it?
Not to have an, what do they call these, alkanes?
Oh, maybe I...
Because you would have
I
to
guess
have
I
at
was
least
looking at
one
this.
C. They have to be connected, so you'd have to have at least one C.
Oh, true. Yeah, no, it wouldn't make sense.
Okay. So y-intercept is not possible in this case. Need at least one C. Number 7. On the following grid, create a graph that shows the ordered pairs and the linear model. So we had 1, 4, and 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7, 16. And we can draw the line. Keep in mind, if we extended the line to the left, we would go through 0, 2, but again, that doesn't make any sense in this case. So let's not do that. We draw our line the other way. We can, whoops, I got my dot in the wrong place over here. So we can extend it on the right side because we can keep adding more C's and then more hydrogens. So there's our line. Page 450. Number 8, use the model for straight chain alkanes to answer the following questions. Now by model, they mean that formula that we came up with, or that equation. So that was
2n plus 2?
2n plus 2, but let's use the h and the c. So h is equal to 2c plus 2. That was our model we came up with earlier. So part A. If an alkane has 10 carbon atoms, how many hydrogen atoms does it have? What should we do to figure that out?
10 divided by 2.
Why would you take 10 divided by 2?
Or 10 minus 2.
And why would you
Because-
subtract 2?
Because of the... I thought
We
the pattern
have
we
10.
had.
We have 10 carbon atoms. What should we do with the 10?
Wouldn't you like? You'd have to add something with the 10.
Look at your formula, the model. What should we do with the 10?
Well, if I would think like 10 times 2.
There you go. We need to substitute the 10 in for the C.
Oh yeah.
Then we can find the hydrogen atoms. So H is equal to 2 times 10 plus 2. What's next?
And the same one, A.
Yeah, we're still on A. We have to finish it up.
2 times 10 is 20.
Okay, so 20 plus 2, which is
22.
22 hydrogen atoms. Oops, can't spell hydrogen. Okay. So if we know the number of carbon atoms, we put that number in for the C, and then we can find H. Now let's look at B. If an alkane has 14 hydrogen atoms, how many carbon atoms does it have?
Wouldn't you put like 14 equals 2C plus 2?
Exactly. We put the 14 in for the H. So 14 is equal to 2C plus 2. And how do we solve this one?
Wouldn't you divide the 14 by 2?
Not yet.
Oh, shoot. Would you add the 2?
Not add to.
Subtract?
Yes, we would. We want to get this 2C, that variable part, all by itself. That means we have to get rid of that 2 at the end. Since it's a plus 2, that means we have to subtract 2. We do that to both sides. 14 minus 2 is?
12.
And that's equal to 2C. What's our next step going to be?
Now you would divide it
By?
12 divided by 2.
12 divided by 2, yes. And you would get?
6. C.
6 carbon atoms. Is it possible to have a straight chain alkane with an odd number of hydrogen atoms? So is there a number that you can plug in for C so that you'd end up with an odd number of hydrogen atoms?
Yeah. Wouldn't you?
Okay, what could you plug in for C so that you get an odd number?
I mean, couldn't it be any odd number?
Well, you can put an odd number in for C, like you can put in a 7, but can you get an odd number for H?
Probably not, because a 7, I mean, like if you like multiplied it, it'd be 14.
Okay, exactly. If you multiply by 2, your number's going to be even, and when you add 2, it's still going to be even.
True. Yeah.
So, no, it's not possible. Multiplying by 2 and then adding 2 will always result in a even number. Okay, how it works. To write the equation of a line in slope-intercept form, given some information about the line. Number 1, write the general slope-intercept form of a line, which is y equals mx plus b. Find the slope of the line. Substitute the slope for m and an ordered pair on the line for x and y. Solve the resulting equation for b. Write the slope-intercept form with the values of m and b included. For example, assume a line passes through -2, 6 and 3, 11. Since the slope is not given, we use those 2 points to find the slope. And it's been a while since we've done that. But the slope is a change in y's over the change in x's. So what they did, they started with the second point. They took the 11 and they subtracted 6. Since they started with 11 in the numerator, then they had to start with a 3 in the denominator. They had to go back and start with the same point. So then 3 minus negative 2. And then they worked it out. 11 minus 6 is 5. And 3 plus 2 is also 5. They divided and they ended up with 1. Slope is 1. Any questions on that?
Nope.
Since we do not have the y-intercept, we will pick a point on the line and substitute it into the equation to find the value of b. 3, 11 is easier to work with than negative 2, 6 since its coordinates are positive. So substitute m equals 1 and the point 3, 11 into the formula and solve it for b. So the y is 11, the slope is 1, and x is 3, and then we can find b. So similar to what we did before, 1 times 3 is 3, and then you'd have to subtract the 3, and that's how they got 8. So writing the linear equation, we get y equals 1x plus 8 or y equals x plus 8. Questions? Some notes. Number 1, the goal is to find the values of m and b and substitute them into y equals mx plus b. If the slope is not provided, use the table, graph, or points provided to find the slope. Number 3, you may need to change the variables x and y to variables that are meaningful in the problem, like the h and the c that we had just a bit ago. Number 4, if you can see the y-intercept from the table or graph or point provided, you can skip the step of finding the value of b. So number 9. Find the linear equation for each situation. So part A, we have the slope is 4. That's good. It passes through the point 0, negative 8, which is wonderful because that's the y-intercept. So this m, of course, is telling you the m, the slope, and this negative 8 is telling you what b is. So we just need to substitute those numbers in and we're done. Y is equal to, the slope is 4, and the y-intercept is negative 8, and there's our answer.
Oh.
So it's nice when they give us the slope and the y-intercept. Now the next one's going to be a little bit harder because they give us the slope, that's a good thing, but they're giving us a point other than the y-intercept, so we're going to have to plug that point in. So we start with y equals mx plus b. So the y is,
wouldn't it be the 1?
so that point is in the form of yx.
Wait.
When you're given a point, the first value would be x or y.
Wouldn't it be y?
No?
Really? I thought it was the y.
No, it'd be x, and then you'd have y. They're always in alphabetical order. Well, I shouldn't say always. It just depends on what your variables are. But the y, whatever's over there, that's your independent variable. So when we're working in general terms with x's and y's, it is in the form always x and then y. So y is,
Negative 8.
and our slope is 4. X is,
Negative 1.
it's what?
Negative, or 1, sorry.
1. There you go. And then we have the plus b. Next step.
Okay, the 4 times 1 is 4.
So negative 8 is equal to 4 plus b.
And then, wouldn't you subtract the, 8 minus 4?
8 minus 4. So we're subtracting 4 on both sides, actually. And b is,
Wouldn't it make it like a positive 4? Because these two...
no, we're subtracting. If we're at negative 8, and you subtract 4 more,
So that'd be negative 4 then?
negative what?
Wait. Wouldn't it be negative 12?
It would be negative 12. So now we have the slope here that they gave us, and now we have the y-intercept right there that we just found. What's our equation? It's going to look similar to our answer for A.
Gonna be B8.
Similar to the answer for A.
Wasn't the Y like this whole thing, right? I mean, I don't know what I'm thinking.
Well, we have our general equation, right? Y equals mx plus b.
Mm-hmm.
We just found our m here, or well, they gave us that, and then we found the b here. So now we can substitute those values in. What do we have?
So Y equals 4 times
Or x, 4x.
or 4x plus negative 12.
Okay, plus negative 12, it's better to have just one sign in there, so minus 12 would be best. That one was a little trickier.
Yeah. Was.
Questions?
No.
Now the next one is trickier yet because they're not giving us the slope. We're going to have to use those 2 points to find the slope. So slope is a change in y's. So what do we have in the numerator?
Wouldn't it be, hope I'm doing this right, 6 minus 4.
No, you have to have both y values. Which ones are the y values?
The 6 and the 10.
6 and the 10. So we need to subtract them in either order. It doesn't matter. So do you want 6 minus 10 or do you want 10 minus 6?
10 minus 6.
Okay, 10 minus 6. So now we have to look at the x's, and we have to go in the same order. So since we started with 10,
Negative 4 minus 8.
it's actually minus a
negative
negative 8. Questions in plugging the numbers in?
No.
Okay, so let's work it out. 10 minus 6 is
4.
over. Now minus negative 8 is really the same thing as plus 8. So negative 4 plus 8 would be
12.
not 12,
Negative 12.
not negative 12.
What the heck? Wouldn't you like subtract it then?
Mm-hmm.
So it'd be
Yes.
4
Would it be a positive 4 or a negative 4?
negative. Because
Now which is larger, 4, the negative 4 or the 8?
the 8.
Mm-hmm. The 8 has a larger absolute value, so we need the same sign. So it's going to be a positive 4. And 4 over 4 is
1.
1. So our slope is 1. And now we're going to have to do like we did in part B.
Oh,
We're going to have to use one of those points along with the slope we just found. Which point would you like to use, the first one or the second?
The first one.
First one, okay. So y is
The 6.
the 6. The slope is
1.
1. And x is,
10.
Careful. You said you were going to use the first point.
Oh,
What is the x?
sorry, 8. Negative 8.
Negative 8. And then we have plus b. So next line,
Wouldn't you so it'd be 10?
10, where's 10
Or
come from?
are we still like figuring out this?
Yeah, we're still
I
figuring
thought
this
we were,
out.
Oh, okay. So negative 8 times 1 is negative 8.
Okay, so 6 equals negative 8 plus b.
And then negative 8. Well, 6 minus negative 8, right?
Or you could say, since it's a negative 8, you would have to add 8.
So,
When you said minus negative 8, that's really the same thing as adding 8.
oh, okay.
So b is?
14.
B is 14. So we found our slope over here, we found our b here. So we plug them in, and what do we have?
Y equals 1 shoot 1 wouldn't it be 6?
No, we're not plugging a value in for x at this point. We're substituting in the m and the b. So this is still going to be an x here.
Plus 14.
There you go. So there's two things you need to find the equation of a line. You need the slope and you need the y-intercept. So maybe they give all that information to you like they did in A, and then it's just a matter of plugging in the numbers. But they might give you the slope along with a different point, and then you'll have to find the y-intercept, and then you can substitute in. Or you may have to find both. You might have to find the slope and the y-intercept like part C. But once you find them, then it's just a matter of plugging back into the y equals mx plus b. Okay, let's try letter D. Write the equation of the line with these points. Okay, so it's just another way to give us 2 points. In fact, we have 4 points this time. So we can pick any 2 points so that we can find the slope. Which 2 points would you like to use?
1 and 6.
Okay, 1 and 6, along with which other one?
3 and 8.
Okay. So we can use those 2 points to find the slope. You can use any 2 points you want to. So again, we have to find the change in y's over the change in x's. So what about the numerator?
Oh,
You pick one of the y's.
the 6.
Okay. You're picking 6, so subtract the other y.
8.
So minus 8. Now the denominators, we're working with the x's.
So like 1 minus 3.
Very good. Yep, you chose those in the same order. So 6 minus 8 is?
Negative 2.
Negative 2. And 1 minus 3 is?
Negative 2. Right.
Oh, yeah, okay, negative 2 over negative 2, which is equal to? 1. So our slope is 1. We also need the y-intercept, which they actually gave to us right there. So we should be able to substitute right into the equation, and we'll have our answer. So what do we have?
Well, y equals Wouldn't it be 0?
Now what's our slope?
Wait. Sorry, 1.
1.
Y equals 1x
1x, yep.
plus oh shoot, we'd have to find b.
Well, we can find b because we know the y-intercept. 0, 5. So what is b?
Wouldn't it be 0?
Not 0.
5.
It's the 5, yep. So this was like part A. Well, except that we had to find the slope. Once we found the slope, then it was like part A.
Man.
Any questions on that one?
No.
Are you on overload yet?
Yes.
Letter E. Horizontal line passing through negative 3, 5. Draw a graph with the horizontal line passing through negative 3, 5. So we find negative 3, 5 is right there. We go left 3 and up 5. Horizontal line goes straight across. So there's our line. Complete this table with points from the line. So what other points are on the line besides negative 3, 5?
Can't it be like 0, 5?
Okay, 0, 5. Another one?
2, 5?
Okay, another one?
1, 5?
Mm-hmm. Another one?
Negative 6, 5?
Okay, negative 6, 5. What do you notice?
That you just use both the lines.
Look at your table. What do you notice?
It just goes like up and down.
What goes
Like-
up and down? What do you mean?
You can just use like this, 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 this. Like
Okay, true. But don't look at the graph. Look at the table.
the y's are all 5.
There you go. The y value is always 5. So write the equation of the line. So we can say that same thing in an equation when we say y is equal to 5. So there's the equation of your line.
Oh shoot, that was easier than I thought.
Yeah, that wasn't so bad after all. Letter F.
Would it be like the same thing?
Well, it'll be similar.
Well, like
This time we have a vertical line passing through 1, negative 2. Draw a graph with a vertical line passing through 1, negative 2. So we go to the right one and down 2. There's our point, 1, negative 2. Vertical line goes up and down. So there's the graph of the line. Complete this table with points from the line. What else is on the line besides 1, negative 2?
like sorry, I had to think for a second. Negative 1, 1.
Negative 1, 1 would be over here. So negative 1, 1 is not on the line. Negative 1, 1 is over here.
Oh, wait. Okay, so negative. No. One. Oh my god, this one's confusing. Okay, so I'll just say like 1, 1.
Okay, 1, 1.
And then 2, 1.
Not 2, 1.
Oh, shoot. Doesn't it have to be on this line, though?
Yes, it does. But 2, 1 would be over here.
Oh, God.
2, 1 would be
Okay,
over there.
1, 1, 2.
Okay, 1, 2.
And then 1, 5.
1, 5. We need one more.
Okay, 1, 3.
1, 3.
Okay, so the x is all 1.
Mm-hmm. So the x values are always 1. So what do you think the equation of the line is?
Okay, so x equals 1.
X equals 1. So horizontal lines and vertical lines are special lines where you're only going to have one variable. A horizontal line will always be y is equal to some number, and a vertical line will always be x is equal to some number. Okay, well, I don't think we're going to have time to do number 10 and 11, so we'll stop there. We'll finish that up on Monday.
And tomorrow.
That's right, tomorrow. It is only Thursday.
I know, I keep getting my days mixed up.